In this video here, we're going to take a look at parametric equations. So before we get properly started here within this video, I do think it's worth pointing out that the material featured within this video here is just largely recapping A-level maths material. Okay, so for parametric equations then, we're not introducing anything new here. So if you're confident with the A-level maths material for parametric equations, then feel free to skip this video. If you do think it's worth having a quick refresher then on parametric equations, feel free to stick around for this video. So to get us started then, you should be familiar with the concept of defining a curve using parametric equations. So this is where the x and y coordinates are defined in terms of an independent variable. We often use t, right? So just recalling that t will crop up quite a bit as we work through parametric equations. Think back to A-level maths. But theta is another common variable that we use. And we call this a parameter. So the parametric equations of a curve are written as follows. So we have x equals p of t and y is equal to q of t. And recall as well that each value of t within the domain of the functions p and q generates a unique point on the curve. And finally then, if we want to find the Cartesian equation of a parametric curve, we simply need to eliminate the parameter t between the equations. Okay. So in terms of an introduction here to parametric equations, like I said at the beginning here, this is just quickly recapping A-level maths material. So nothing new here that we're introducing, just recapping A-level maths material. So there we have it. That covers everything that we need here for parametric equations. Let's just take a quick look then at one practice question. So let's just have a go then at this one practice question here for parametric equations. So as we can see then for this question here, all we want to do is find the Cartesian equations of the curves given by these pairs of parametric equations. So to get us started then for part A here, so let's just start by writing down the parametric equations here. So we have x equals 2t squared, and we also have y equals 4t here. So what I need to do here then is rearrange one of these two equations, making t the subject. And once we do that, then we then substitute that into the remaining equation. Okay. Now, generally speaking, what you want to do here is choose the one equation that is easier to work with, which in this case here would be y equals 4t. Okay. So let's rearrange this equation here, making t the subject. So if we do that then, what we get here is t is equal to y over 4. Okay. Nice and straightforward there. And then what we do here is we substitute that into this equation here. So in that case then, what I get here is x equals, so I get two lots of t squared. So t is equal to y over 4. I get two lots of y over 4 all squared, like so. Well, y over 4 squared, that would be y squared over 16. So I get 2y squared over 16. And this is for x here. Okay, so clearly we can simplify this, right? This is just the same as y squared over 8. We get y squared over 8 here. And then it might look a little bit neater here if we just times through by 8. So in that case, then what I get here is y squared is equal to ax there. Okay, and there we have it. So that gives us the solution to part A. So moving on now, let's have a go then at part B. So pretty similar for part B, right? So again, let's just start by writing down the parametric equations here. So we have x equals 10t. And we also have y equals 5t squared. So again, I'm just going to start here by rearranging one of these two equations. Again, just choosing the easier of the two equations, which in this case would be this equation here. So if we do that then, what I get here is t is equal to x over 10, right? We get x over 10 there. And all we're going to do now is substitute that into this equation here. So in that case then, what I get here for y is I get 5 lots. So 5 lots of x over 10 squared, like so. In this case here, I'd get x squared over 100, and it through by 5, and I get 5x squared over 100. So 5x squared over 100 here, like so, which clearly we could just simplify to give us x squared over 20. We get x squared over 20, And it might look a little bit neater here if we times through by 20. So in that case, then what I get here is x squared is equal to 20y there. Okay, so that gives us the solution to part B. And then finally here for part C, again, let's just start here by writing down these parametric equations. So we have x equals 4t and y is equal to 4 over t. And this is for t not equal to 0. Okay. So again, just as we've done here for the previous two parts, right, we're going to start here by rearranging one of these two equations. And again, just, pick the easier of the two equations, which in this case here is probably just this one. So rearranging this here, making t the subject, what I get then is t is equal to x over 4. Okay. We're now going to substitute this here then into this equation. So what I get here for y is y is equal to 4 over t. So t then is x over 4. So I get 4 all over x over 4. Okay. So dividing by x over 4 here is just the same as times in by 4 over x, right? So I've got 4 times by 4 over x, like so. So this here then just gives me 16 over x. So y is equal to 16 over x, like so. And again, we can make this look a little bit neater here, just timing through by x, right? So in that case, then what I get here is xy is equal to 16 there. Okay. And there we have it. So that gives us the solution there to the very last part of this question, part C, and the solution to question 1. And that actually brings the end then of this video here on parametric equations.